Hi guys, today we're going to go over lesson 3.6, linear pairs and vertical angles. So we're going to start with the definition of opposite rays. So let's draw a ray. You start with the endpoint and let's just go to the right. Let's name this A, B. Now an opposite ray would start at the endpoint and just go in the opposite direction. So technically you have two rays here. You have AB and you have AC. Remember, you always name it starting with the endpoint. But when they come together, it looks like just a line. So there's often like questions, like this, and it just says name the opposite rays. So it's just exactly what we just did. You look at it, it looks like a line, but how do you know it starts, at Y or X or Z? Well, if I started here, there's no way to name that ray. So Z, and then you really don't have another point. And again, if you start at X, you have X as an endpoint, but you don't have another letter. So the only letter that really works for both rays would be if you start at Y and one goes to the right and then the other one goes to the left. Now, whenever you have a linear pair, they talk about opposite rays. It says two angles that have a common side, but their other two sides are opposite rays. All right, so let's put this in easier terms. It's two angles that come together, and they have to be adjacent. They have a common side, which we know that means adjacent. And they share a vertex, and together this equals 180 degrees. So my personal definition is two adjacent angles that equal 180 degrees. Now, this is different from being supplementary because supplementary, they could be adjacent or non-adjacent. Now, when dealing with proofs, we're going to use theorem 5. And it says the angles of a linear pair are supplementary. Now, let's go back to supplementary. Whenever you have supplementary, the definition is just two angles that equal 180 degrees. So, yeah, we can do this picture that we have for a linear pair, but we could also split these apart. If I have 100 degrees and then another one that's like 80 degrees, together, these two angles are supplementary. But linear pair, let's break down the word. Honestly, linear means a straight line, pair means two. So it's two angles that make a straight line. So that's an easy way to think about it. Okay, this lesson's very short, by the way. The next one is vertical angles. Now, vertical angles, let's read the definition, then I'll give you my definition. It says two angles with the side of one angle are opposite rays to the sides of another. And I feel like this is just a really difficult way of saying the situation. So my definition is here. Non-adjacent angles formed by intersecting lines. So remember, we said what adjacent was. Adjacent appears when they have a common side and a common vertex. So if I'm looking at this, 1 and 2 are adjacent, but 1 and 3 are non-adjacent. So you have intersecting lines that are non-adjacent. Now, I'm going to go ahead and spill the beans about the next theorem. Vertical angles are always congruent. So the way we can mark this on a picture is by putting little congruent marks. I know angle 1 is the same measurement as angle 3, and I know angle 2 is the same measurement as angle 4 because they're vertical. So as soon as you hear the word vertical, you need to just know, hey, those are always equal. Theorem 6 is something that we're going to use over and over all year long. It's one of the few that you're going to memorize and just know by heart. So go ahead and try to memorize. Theorem 6 is vertical angles. Now, whenever we're doing a proof, I can tell you we never use the definition of vertical angle. We're always going to use theorem 6, that the vertical angles are equal, because within proofs, we're always just saying that the angles are equal to each other. Now, I have a problem here that my Core 40 class was doing today, and this is the kind of stuff that's always on iStep and SATs, so I thought I would go ahead and show it to you, even though the person that wrote your textbook really doesn't give you tons of algebra work to do. It's more deductive reasoning, like trying to think through word problems. But if you have a problem like this, and they tell you that the vertical angles, I went ahead and drew this out and marked that the two angles were equal. Again, as soon as I see that they're vertical, I know they have to be equal in measure. So remember, this little M means measure. So the measure of angle ABC is 3x plus 8. So I labeled it. And the measure of angle EBF is 2x plus 48. So we're going to write an algebra equation. We know that they're equal to each other. So let's just set up an equation like that. The one angle is equal to the other. So now we're just going to do our algebra skills and solve for x. And it looks like the answer is going to be 40. Now, I want to find the actual measure of each angle. So if I were to take the 40 and plug it back in, so I would do 3 times 40 plus 8. So 3 times 40 is 120 plus 8 is 128. Now, I can predict the next answer is going to be the same thing if I did everything correctly. 2 times 40 plus 48, so 80 plus 48 is 128. So that makes sense. Okay, so now you know your assignments on Canvas. You're going to apply everything in this lesson to your assignment. If you have questions, feel free to reach out. I'm available at the end of every single class period to take your questions live as well. Thanks. Bye-bye.